Okay, my video for today is going to be on UniML, Universal Modeling Language, which I don't get many views on, but that's kind of par for the course. And so let me just jump right into it. Let me first go to, not here, where do I want to look at this? Aliens, parasites, oh, that's a movie. Where category theory, that's what I was looking at. So if you go look at category theory, a lot of the videos are old, and there's going to be some dude or professor, man or woman, scribbling on a whiteboard or a chalkboard, talking, and then you oftentimes all they're doing is writing what's in the textbook. So if you go by the textbook, it's a lot easier and you can see things better. So let me back off from here, just show that. So and if it's more modern, you might get a little bit better graphics like this. And some people try to make it a little more entertaining, and they put little cutesy things in it, like.
But we've now got an equivalent definition.
So they have cutie things, and this, instead of doing a whiteboard with a pencil, a marker, or on a chalkboard with chalk, and they put cutesy things in like that little person. But it does, to make it a little more interesting. But I'm thinking, okay, that's not the UniML way. Let me go show you UniML way. So, and this is on this. So let me go back here, and the subject I was looking at was products. So in products, you'll see they kind of look like this.
Someone just asked a fantastic question on my Fibonacci functor short.
Okay. When I point to it, it goes away. Thank you, YouTube. You're never helping. But there. Let's see if we can get there and see this.
In this video, we're going to do a...
So you can kind of see this. You have the C and F1 and F2, and then you have the cross product, and you have these. So I kind of use some notation here. So let me jump into the UniML version of that. So before I do that, and I'm learning a lot from category theory. It's pretty cool, even though the videos aren't all that great. And the textbooks are better. But oftentimes, this is the view I normally show in UniML. It's like using this is called a folder. There's the name of the folder, the owner of the folder, and here's the elements. And like the set, it could be a set or a collection, a grocery list, milk, bread, chips, these are, I call them tangos. I forgot what tutor. All those, they're an acronym. They stand for something. Never mind what. And but in category theory, usually they don't show the elements of the set. They just show the sets. But you can do that in UniML. I just never typically do it, where you just hide the set. And when you do that, you don't get a string break, because you're not really breaking the string. You're just hiding the next tier down. So, but you kind of want to know. So I put these little, I called them breadcrumbs. Breadcrumbs are little things. A lot of times in this display, when you hide something, it goes away, and then now how do I unhide it? There's no, the thing that shows it is gone, so how do I bring it back? So a breadcrumb is like when you hide something, it doesn't totally go away. There's a little bit of breadcrumb to get you back. And so this breadcrumb here, I'm calling a bubble bracket. There's your, you can see it here. If there's no bubble bracket, it's a leaf node. It's not a folder. It's just an element in the set. If it's on the left side, the folder is hidden. And but if you go to the right side, it unhides. And if you really want to expand upon it, you start seeing the internal structure of the folder, where here's the folder, but what it really is two waterfront properties that are kind of, so you're going in there and looking at the actual internal structure of the graphics that you're seeing. Here you're seeing the sort of the functional view. Here you're seeing the how the sausage is made, just making the display. So and then you could go between those. So category theory's got me thinking using this view more. So yeah, category theory. So given that, I'm going to be showing this view here. I'm not going to be showing the elements inside the sets. So here you saw that kind of diagram I just showed you previously. Let me see if I can find it again. There, see that diagram there? Here it is here. But here, important is I've rotated it, but you could rotate it either way. And this is called a swim lane island. It's named because here's a swim lane. Think of a river, and the river splits. One channel goes this way, one channel goes this way. It joins, makes an island. And by the way, the naming convention in UML is I want to name things that are descriptive. Use things that you already know. People know what an island is. They know what a breadcrumb is. They know what a pearl is. And then I pick things that are analogous so that you're already ahead of the game. When I say swim on an island, you think, oh, an island? I know what an island is. And it's like a swim lane. I kind of know what a swim lane is. People go swimming. Swim lane island. So the naming isn't just cutesy. It's functional to help people learn things. So here, my tango, this is Dr. Frack, is pointing here. This here is a subset. So we have this, and I'm not sure, my category theory, I'm just learning it, so I might get some of that wrong. But this is an object. Category theory, you have objects and arrows. That's it, objects and arrows. And so I put in here this isn't a category hex number, but it's something. I don't know what you call it, category theory. It's a folder, it's a diagram. I just call it category theory drawing. I could say drawing of a product, example of a product. You can make this as long as you want. So, and these are called docs here. And you put a name tag. This is a name tag. This is a name bubble. It's just the shape of this. It just has different shapes. So, hex number, like a game map, the hex might be A3 or bingo card, B12. That's you got a row and a column. You can see here we have rows and column, row number, column number, and then the cross product is to put the two together, and that'll give you like an actual square, like on a checkerboard or chessboard. You might have row 1, column 1. That would be like 1, 1. That would be a square on the chessboard. I could have shown that. I meant to show that, but I'll do that in another video. So, and then when you select something, there's different levels. When you select it, you could get highlighting of the swim lane, and this is called the crosswalk. But I'm not showing that, but I am showing that when you click on it, you get, this is called a bookmark. And it has a diamond, or they call it push pin. You just kind of stick the push pin in. It has a little message here. Normally I just put C. If you don't know what C, go look over here. It has bins, and this is called routing. I routed it this way. I could have routed it down this way, and that's called routing. And this is called extension. So here's the big name, hex number. And I just said, we'll just use H as abbreviation. That way I could, and I'm picking the same number. H is also what I used here in the diagram. So there, so this is in UniML, this is in the category theory world. And so you could have your cake and eat it. You could say, I like categories. But sometimes I lose the bubble. I kind of forget where I'm at. And so this UniML model could help me get that. So we think, okay, that's cool. So let's say we click on this one here, and then boom. Now we don't show this bookmark, we show this one. Now you can show multiple ones, but it gets messier. So here's R. Okay, that's cool. So let's see, we've got that. So let's go to the next one. And it's this is an object. It's not an arrow. And there's C. Okay, where are we? Here we are. And now here's another object, category theory object. They're modeling it. This is not a category theory object in UniML. It's a UniML construct, but it's modeling that, it's depicting that, it's playing that. It's like an actor. This is like Richard Burton playing King. What did he play? Beckett, or whatever. So that's the role. He's playing the role of this cross product in the object in the category diagram. So we could go see where we're here, put it here, and now guess what? These are not objects. They've changed roles. These are kind of like, and these are arrows, or they're playing the role of an arrow. And you can see these have the T set. T cup is kind of the tail of the arrow here. And the handle is like the feathers of the arrow, and the saucer is where the cup goes. You don't move the saucer to the cup, you move the cup to the saucer. because it goes on top. Oops, I can show that here. It goes on top. You don't move in real life, so you have directionality here. So yeah, okay, we've moved over, and this is an arrow. And this one is F1, a function, or functor, or whatever. And there's F2, where am I here? Let's see. And we move on down here, there's G, and lowercase g, there's R. And so this connects the dots. You're seeing, okay, there's R, and there's C, and that's the end of this. And you think, oh, if I shift click, I can see two at once. And I change the colors here, so that's kind of nice. You think, so there's two ways of doing this. You could have clicked on here, like hex here, and we would have gone back up to here. Or you could have clicked, let's just click on here. We're going to click on C. And I clicked here, or I could have clicked here on C, and that would have jumped me back down to, see if I can find this. There. So I clicked on the C, and it's like, where's C in this diagram? So you can navigate this way or that way. So, and then the idea is, trying to write all this code to do this would be really hard. Yeah, it would have been 10 years ago, but not with the chatbots we have now. They could, yeah, it would cost some money to run it, but you get one of these powerful chatbots like Opus 4.8 or if the new one they got, I forget its name. It's not available now, but if there'll be newer ones, they could crank all this stuff out and write the code to do this. And then instead of going back to the 1960s or the 70s or 80s on the board, you could have an interactive model. But not only that, see, let's go back to here. These tangos, they could be animated too, and they could talk to you. I mean, they could be like your lecture. I mean, just saying, people saying AI is going to replace people's jobs. Well, instructors in college that scribble things. And I remember this math class I took in college. The guy would write with both hands, and I couldn't read a word he's saying, and he talked really fast. Terrible instructor. Probably could have been a brilliant mathematician, but a terrible instructor. So I'm not saying that. So the AI might replace the mathematician, but it certainly could replace the instructor. So the human could be there too. I mean, it's not mutually exclusive, and that's what I think is going to happen. The AI is not going to replace the human; it's going to supplement the human. So the human could be there, and then the human could interacting just as students do, or it could be on somebody's desktop or on their cell phone. And then the other thing is you could hide things. There's other things in UniML you could do. I'm not showing them in this video. This video is getting long enough. So, so this just, and these aren't these. These are like Tinker Toys. So if you build, you can use Tinker Toy and say, our Lego blocks. And you build it like the space shuttle, or the with Lego blocks. The Lego blocks aren't the space shuttle. They're just built. You're using them to build a model of the space shuttle. This white pearl is not. This right, let me go over here. Go up to here. This, I'll go up one more. This white pearl here is not this object C in category theory. It's just pretending, it's playing that role. It's saying, okay, I'm taking on the role of that, but I'm just a Lego block. I might take some other role later on and model something else. I might some different paradigm, or whatever. So I think I've covered all this, and it's really tedious for me to build these. Of course, once you build them, I just kind of copy and paste and modify them. But once again, it takes a long time to draw these because they're canonical, which means I just don't make up things. There's a format to do these, and they're detailed. There's lots of details, and getting all those details right is tedious. But that's what computers are good at, and particularly LLMs, large language models. They should be able to build these things on the fly. So you just give a prompt, say, build a UniML diagram of a example of category theory illustrating a product. And so it's not too much of a stretch of imagination to think that it says, okay, there, it drew this diagram for me. Said, now create some tangos and use those to narrate me through those. And then the other thing in tangos is you might be able to click on the tango and move it and saying, what's this thing here? And then the tango could tell you in words, written words, or tell you, or have speech, or both. It might say, this is a split black pearl. A split black pearl is, well, why did I split it? Well, if I didn't split it, you couldn't see it because it's sitting under this landing. So these are called junction boxes. There's a split junction box. So that's one of the things that UniML does is you don't include things like this. It's like when you move this. Let me just show you what happens if I expanded this. That's like, let's move this. I want to make this drawing bigger. So I stretched it up to here. And what you would have seen happen is let me click on here. It would have added this here, okay. These are underpasses, so that crosswalk goes under here. So this is sitting on top of this, including, you can see the crosswalk here, but it's included here. But it knows it's included because it's putting the underpass here. And so it's smart. And you can hide things. You say, I don't want to see all these. I just want to see one. So you could have, let me just do this, hide these, and this, it would have just do this, and it would have put string break here. Let me just show that. Break in the string. Doop. And here. So I don't need to see all those. This is kind of like ellipsis. So there's my string break. When you do that, it probably changes the color of this guy, just to let you know that. So we'll change its color to go back to your home. This would change. Okay, oops, wrong one. This one. Of course, this would have gone away. Da-da-da. So, okay, we just hit all this stuff because we don't really care about it. And so, if you want it back, or you could like click and drag this. Say we dragged it down to here. And so that moved the string break to here. And what was here goes back, whatever that was. Let me go back here. Let's see, where is this? This is HR, so this would come back. Boop. Showing you this. So here, I'm back again. Oh, and essentially all these would stack on top of each other. So when you hide them, it's like all these just would be stacked on top of each other like this. And it might close up this distance here too and say, oh, we'll just shorten it, shrink our diagram so it's not as doing this. I'm just going to do it kind of klutzy. So, and this would have gone red probably. So there's our string break. You get the idea here. So, and you could even, then like if you clicked on this, and if it's hidden, it might, since you clicked it, it's, oops, we got to bring that back. So it might have brought this one back here. So that's H. This is F2. Let's say we clicked on F2. Where is F2? Oh, that's already not hidden. Say we clicked on C. So copy. So we clicked on this. So boom, C would come back because you clicked on it. Oops. Here. And so you still have the break here, but you brought C back. So this would come down here. Da da da, and then these. So you get the idea. And it's, this part would come back too, so we'll show that. See, this isn't rocket science. It's just, instead of me having to draw all this stuff, the computer does it for me. Oh, I didn't want it here. Where was that? Yeah. Is that where it was? Yeah, C. All this tedious stuff that the computer is really good at doing, it will do for me. So I don't have to. I could have pulled that. So anyway, I'm going to end the video here. So let's see, I'll just undo a lot of that stuff. That's pretty close back. So anyway, that's my video, UniML, and it's like, I'm not going to build the software for this. That's not my thing. Building software, work at a higher level, inventing. You got all these smart people with their chalkboards scribbling away, or their magic markers scribbling away, that can build this stuff. But they're not the ones that seem like could invent the better mousetrap, how to show it. So that's my job, is come up with better mousetraps, not to catch mice. Let somebody else catch the mice, build the mousetraps, catch the mice. I just design, come up with the idea of the better mousetrap. So on that note, let me end my video here. And let's see, where am I? I'm here under, so at any rate, have a great day or night or wherever you are. And hope the videos, yeah, my video's not too polished. It's kind of rough around the edges. But once again, this isn't what I'm trying to do. I'm not trying to make slick videos. I'm trying to work at the frontier, bleeding edge of how to use AI and visualization and get human interfaces, man-machine interfaces, we used to call them, or whatever they call it now. Can't keep up with the terminology. I'm always behind. But on that note, let me end.